Hey kids, we're back in Mr. Murray's math land and moving on with our derivative rules. Today we're talking about two different rules, the product and the quotient rules. And so we'll start with the product rule, and it's for finding the derivative of a function which is expressed as the product of two variable expressions. Yeah, sounds nice enough, right? And I'll look at question one first before I introduce the rule. Just to drive home this point that these product and quotient rules, if you can avoid using them, if you don't have to use them, then that's always preferable, you know? So don't make things harder than it has to be. So number one, for example, is y equals 6 times cosine of x. 6 times cosine of x. 6 is a constant, not a variable. So we've been doing this derivative all along. This does not require any special rule. So hey, this should be nice and easy. Y prime or dy dx is equal to 6 times the derivative of cosine, and that would be 6 times negative sine, which will give you negative 6 sine of x. Done. No special rules required. However, if you look at the difference in number 2, this is 6x cubed times cosine of x, and that is the product of two variable expressions. 6x cubed and cosine of x. Both have variables in them, and it's not just, hey, take the derivative of this, take the derivative of this, because that's not what we really did here. The derivative of 6 would be 0, and so I'm not just doing 0 times this, otherwise I'd be left with 0. So this requires what's called the product rule. And the product rule is, it's pretty easy, you know, easy enough to memorize. If I'm doing the derivative of f of x times g of x, then it's really pretty simple. Both derivatives are going to get represented, but it is f prime of x, the derivative of the first function, times the second function, so f prime times g, plus the first function times the derivative of the second, f times g prime. So that's a simple enough rule to remember, and it's fairly, easy. It's like, hey, the derivative of one times the other function, the derivative of the other times the other, and you add those two results together. But one thing in calculus, it's kind of a cumulative course, so this is something you're going to need to be able to use off and on throughout the whole year. And unlike some other AP exams, you do not get a formula sheet of any kind, a reference sheet on the exam. Everything needs to be memorized. So, similar to those, trig unit circle values, I just want you to have a good way to memorize it. So whether or not you use this particular little thing I do, that's totally up to you. So I like to do this, and you'll also see why when I do the quotient rule, how it's a similar thing. The first one, I guess I could call it F, but I just tend to call it A. The other variable expression, which would be cosine of x, I call b. And so off to the side, and you will see that, they get more complicated. So sometimes this organizing off to the side can be nice. I say, hey, a is 6x cubed, and now its derivative, a prime, is 18x squared. The other function b is cosine of x, and b prime, its derivative, is negative sine of x. And now the derivative of this entire function, so y prime, of course, don't forget your notation, is equal to the product of these inner expressions. If I've set it up this way, these are the inners and these are the outers. Product of the inners, which would be 18x squared, cosine of x, plus the product of the outers, so plus 6x cubed times negative 6 sine, and that will give you, of course, negative 6x cubed sine of x. And of course, that's just the rule that was presented here. But I find if you sort of make a routine, it just tends to stick with you, that no matter how complicated the functions get and how much you need to organize, if you do this sort of thing, you find a rhythm that you do every single time, it just becomes like muscle memory. So, keep an open mind, and at the end of the day, you find whatever way it takes to get it done for you. Number 3 here, this is a product of two variable expressions, so you certainly could use the product rule. But my question to you is, do you need to? And that's what we're all about here, is the recognition. You've got all these tools now we're adding to your toolbox, but when do I really need to use what? And to me, this could be just done easily by distributing 4x to the 1/2 and then using the power rule. So 4x to the 1/2 times 3x squared will give you 12. X to the, now 2 plus 1/2 is 5/2 minus 4x to the 1/2 times -5 is -20 x to the 1/2. And you see now it's just the power rule. You've been doing these already. And so dy dx or y prime is equal to just power rule. 5/2 times 12 is going to give you 30. X to the, subtract 1 from that exponent. So subtracting 2 halves, 3 halves. 1/2 times -20 gives you -10. X to the, subtract 1 from 1/2, you have -1/2. Good final answer, right? Wrong. We got to change that negative exponent. At least in my world. Your teacher may say differently next year, and that's totally fine. So I like to rewrite this as -10 over x to the 1/2, or if you want to change it back to root x, doesn't matter. Radical form or rational exponent form, all good, but I don't like negative exponents. So there we go. Nice. Number 4 here, this is y equals pi x cubed. Now, do I need the product rule for that? No. Pi is just a constant. It's an irrational constant, but it's just a constant. This, however, I do need the product rule for this portion of the derivative. So this is one where it's just good to be organized and stay on top of things, not get overwhelmed, and go one at a time. This portion right here, easy, power rule. So y prime equals 3 times pi is 3 pi x squared. Now doing the derivative of this part requires the product rule. So, you know, if you can do it in your head, fine. If you like to do the little organization off to the side, fine. Now be careful with this negative right here. There's 2 ways to handle that. You can either, you know, put a negative here and then do the whole product rule and then distribute the negative, or sort of consider that negative part of your first function. So a is negative cube root of x. That's what I like to do, sort of include the negative here. And I'm getting ready to do its derivative, so I'm just going to call it negative x to the 1/3. And its derivative, a prime, is negative 1/3 x to the negative 2/3. And you might already start to say, hey, we're going to change that, and that's fine too. You might leave it. For now, whatever. B is the other function, and that's sine of x, right? This was a, this was b. And b prime, derivative of sine, is cosine. If you haven't made that connection, only when you take the derivative of cosine do you get negative. And that's actually going to be a little helpful trig rule when you learn all the other trig functions. When you take the derivative of any function, the derivative is negative, whatever the rule is. So now for this portion of it, the product rule, product of these inners, which would be negative 1/3. So negative 1/3 x to the negative 2/3 times sine of x, plus the product of these outers. And again, that's going to be plus this negative. A little scrunched in there, but that's not my final answer anyway, because I'm going to change that one little negative exponent. So if you can do those things in your head as you write, fine. If you like to take an extra step because you don't want to make a silly mistake, that's obviously something I recommend too. So just moving this to the bottom here, you know, you can keep it as a coefficient. You can make it all one big fraction if you want to put the sine of x in the top, but the 3 is in the denominator, x to the 2/3 in the denominator. And then this minus x to the 1/3 cosine of x. Change it back to cube root if you like. But there we go. So nothing is really too hard. It's more about just staying organized and not making silly algebra mistakes. That is probably one of the biggest things in calc, watching those silly algebra mistakes. Okay, so product rule, not too bad, right? Product of inners plus product of outers. Inners plus outers. Okay, so if you learn a product rule, that must mean you got to learn a quotient rule, taking the derivative for a fraction or a quotient of 2 functions. Now, again, I'm going to start with one without teaching you the rule. This is certainly a quotient, but do I need any particular rule, or could I have done this before today? y equals 6 over x, hopefully you're saying, yeah, I could just bring that x up and use the power rule on this. So that's 6x to the negative 1. Y prime is negative 6, x to the negative 2. And of course, we're going to rewrite that as negative 6 over x squared. Move that back to the bottom, make the exponent positive. Nice. Okay, so again, notice the result isn't just, hey, take the derivative of the top, take the derivative of the bottom, and you're done, because the derivative of 6 would be 0, and the derivative of x would be 1, and I got this. So here is one little pattern to notice. Look what happened to the denominator of the original compared to the denominator of the derivative. It was x, it became x squared. That is something that is actually true. If you are doing the derivative of f of x over g of x, the result of the derivative of a fraction is going to be a fraction. It's going to be a big fraction. Yeah, it's a fun rule. And whatever your denominator is, it's actually that same denominator squared. Okay, so the numerator, however, will be very similar to the product rule. The numerator portion of it is very similar to the product rule. And here's also why I like that little a, b thing, because it organizes in a very similar way. That if a is the top, which is f of x, and a prime is f prime of x, and b is the denominator g of x, and b prime is g prime of x, then the numerator is going to be the product of the inners, which would be f prime of x, g of x. But here's the difference. It's minus the product of the outers. And that's, if you're doing subtraction, the order matters. So if you're setting this up, it's got to be inners minus outers, which would be f of x, g prime of x. Now look, plenty of people will just memorize the rule and use it without doing any of this stuff off to the side, and that is totally fine if you can do it. You do it enough, it's like anything else. Just like with the trig unit circle. Some people use the chart, some people use the circle, some people just know them after a while. Whatever, as long as you can do it. There's another little trick, some teachers use, and I had a professor who used it. Not bad as far as memorizing the numerator portion of it, and it's low d high minus high d low. He would say over and over again, low d high minus high d low. And what that means is the low refers to the denominator, the high refers to the numerator. So low g times d high. So low times derivative of high. Low times derivative of high minus high d low, minus the high function times the derivative of the low function. Whatever. Yeah, that's kind of cool. So, hey, there it is. Quotient rule. Nice. Number 6. Notice I could not use my power rule for this because you can't just bring each term up. This cannot be made into a power rule. It's not a mu, right? It's not many over 1. It's 1 over multiple terms, and you can't break up the denominator. So this is prime quotient rule territory. And so a is the numerator of 6. A prime is the derivative of 6, which is 0. B, 3x squared minus 5, the denominator. B prime, derivative of that, which is 6x. Our derivative of this whole function, y prime, is, don't forget about the denominator. Sometimes I like to do that first, just to make sure I don't forget. It's going to be 3x minus 5, but squared, right? The numerator everybody focuses on, but sometimes they forget about the denominator. Okay, so the numerator will be the inners. 0 times this is 0 minus this times this. 6 times 6x. Inners minus outers, and that will be minus 36x. And 0 minus 36x is, of course, just negative 36x. And I'm going to leave the answer like that. If you want to FOIL out the denominator, go ahead, but probably you're going to want to leave it that way, not just for time's sake, but also for factored sake, Sometimes things will reduce, but good to go like that. Now number 7, hey, it's definitely a fraction, it's definitely got variables. Do I have to use the quotient rule? And by the way, I certainly could, But do I have to? No. This is a mu, many terms over 1. I can break that up and divide. And so 3x to the 6th divided by 5x cubed will be 3/5. X to the 6th divided by x cubed is x cubed. Minus 8x divided by 5x cubed is minus 8/5. X divided by x cubed is x to the negative 2nd. I'm just getting ready for that power rule. This is still just y equals, which is why I didn't bother to write anything there. It's still y equals. But now the derivative y prime is power rule time 3 times 3/5, 9/5 x squared. Negative 2 times negative 8/5 is positive 16/5 x to the negative 3rd. Subtract 1, you get negative 3. Can't leave that. If you fixed it all in your head, that's fine. This is 16 over 5. Move that back to the bottom. And there we go. There's our derivative. Take a look at this one, number 8, last one, just to see another example. This you cannot break up. So this is, again, where we really need the quotient rule. And so a is that numerator of x squared minus 1. A prime, 2x. B, the denominator, 3x plus 5. B prime, 3. And now y prime is, make a big fraction bar, denominator, 3x plus 5 squared. What's up top? Inners. So that's going to be 2x times 3x plus 5 minus outers, 3 times x squared minus 1. And you know, these we're going to distribute, we're going to combine. Sometimes things are going to simplify. So these you really should be distributing and trying to combine these. So that's going to give you 2x times 3x is 6x squared. 2x times 5 is 10x. Distributing negative 3 minus 3x squared. Negative 3 times negative 1, positive 3. Combine those like terms. 3x squared plus 10x plus 3 all over 3x plus 5 squared. And you could check to see if that factors and maybe reduces, and it's not a bad idea. It actually does factor, because 3 times 3 is 9, and what multiplies to 9 and adds up to 10, that's 9 and 1. This will factor by the AC method, but neither of those factors will be 3x plus 5, so if you want to not bother factoring it, because it won't reduce. There you go. So there we go. We've seen the product rule, quotient rule, when we definitely have to use it, when we don't have to use it. And so hopefully it gave you enough to get a good feel for how to do it. But as always, you know, practice, practice, watch the algebra. And if you got any questions, you just ask. Have a good day, kids.